Hello friends, in this question we are asked to calculate di by dt at t equals to 0 plus, okay, and the circuit shown here consists of an inductor and a capacitor and a current source which is u of minus t. Now this u of minus t can be drawn as shown here. This is t equals to 0 and this is t more than 0 and this is t less than 0. Okay, so this current source becomes 0 after t equals to 0. Okay, and before that it has a constant value of 1 amps. Okay, so it has a constant value of 1 amp, so and that exists for a very long time because this current will exist forever on for t less than 0. Okay, so what does that mean? It means that before this t equals to 0, steady state was reached. Okay, and steady state reached means this inductor is going to behave like a conductor or a short circuit, and this capacitor is going to behave like a open circuit. Okay, so let us draw it. So this is 100 ohms. Okay, this is my inductor equivalent. Okay, and this is my capacitor. Okay, this, if I say this is VC, okay, this is open circuited, and this is 1 amps which is flowing. Okay, so this is when the steady state is already reached. Now what we can do here is we can calculate our VC. Okay, VC is going to be the voltage across the capacitor, and you can see that this current source will flow, this current source will deliver current across this 100 ohm resistor. So this voltage drop is going to be 100 into 1, and that same voltage is going to appear across the capacitor. So the voltage drop across capacitor is equal to 100 into 1 is equal to 100 volts. Okay, also you can see the current through the inductor is going to be I can say 0 minus. 0 minus means just before this current source is removed. Okay, is going to be 1 amps. Okay, now these two things are known to me. Now what happens at t equals to 0? This source is value goes to 0. Okay, the amplitude goes to 0. Then let us see how the circuit looks like. So at t equals to 0, or say 0 plus, then this circuit is going to look like this inductor. Okay, and this is 100 ohms and this is my capacitor. Okay, and this already has a 100 volt of voltage across it, and there is no current source now. Okay, now let us say the current flowing is I of t. Okay, now what I can do is I can apply my KCL KVL here in this loop. Okay, so what I get is 100 is equal to I of t into 100 plus L, this inductance L, di of t over dt. Okay, now now see, the current which was flowing in the inductor before the switch was closed was 1 amps. Okay, at t equals to say 0 minus. Okay, just before the switch was just before the current source magnitude went to 0. Okay, so the current is going to be same at t equals to 0 plus 5 because the current cannot change instantly. Hence, if I write this equation for t equals to 0 plus, then 100 is equal to I of t equals to 0 plus, okay, into 100, okay, plus L di by dt at I equals to 0 plus. Okay, now this current is already known to me at t equals to 0 plus is 1 amps, so it's going to be 100 is equal to 1 into 100, okay, plus L di of 0 plus over dt. Now this and this are same, so L di of 0 plus over dt is going to give me 0, and this implies that now this implies that uh, L di 0 plus over dt is my equal to 0. So this implies that di over 0 plus over dt is going to be 0. Okay, So the option D is correct. Okay, so this is how you can proceed for a problem like this. Okay, so thanks for watching.